We are going to talk about critical path. So it's a very interesting agenda that we have, and I have tried to make it short and crisp as well. So critical path is the longest duration path and also the shortest time to complete the project. From the real life perspective or the PMP examination perspective, critical path is extremely important. So what we are going to discuss here is that how we can identify a critical path in a project. So it can be done using these three distinct operations or activities here. You calculate the forward pass, and then you calculate the backward pass, and then we calculate float. So let us see what this forward pass or backward path is. So I have a sample project here, very simple here. So I have task A. When the project kickstarts, I have task A and D starting. Completion of that will lead into the start of B. And when the B completes, your C and E will start. Completion on C and E will lead into the start of F, and then our project will be finished. Now we need to identify what is a critical path here. So to identify critical path, first of all, we are going to calculate the forward path. Forward path means for each task, we will calculate what is the earliest start date and early finish date for each activity. It means earliest possible start date for A, and starting at this, what is the earliest time in which task A can be completed. So we are going to do this for all activities. Okay, let me just make some changes for task B. Okay, there we go. So we'll do it for all the tasks here. I'm so sorry. So there is some goof up here. So let us calculate this early start. Starting on project, when we are starting the project, on the day one, task A will start. Having duration of 6 days, the earliest it can be finished is day 6. Why day 6? Because day 1 is inclusive. So you can count it starting on day 1, 1, 2, 3, 4, 5, 6. The task A will get over on day 6. Okay, and the way you can another way to calculate this is early finish is equal to early start, that is 1, plus duration, that is 6 days, minus 1. Because we are starting it on day 1, that's why we need to do the minus 1. In some of the projects or some of the people, actually they suggest that you start from day 0. In case if you are using day 0 as a starting date, then you need not to do this minus 1. It is just simple EF is equal to ES plus duration. Again, there is nothing right or wrong. This is a point of debate also, that we should start from day 0 or day 1. There is nothing right or wrong. I stick to the policy of starting at day 1. So I'll go with that. In case if you want day 0, you can just make some changes to that and you'll get the same results. So starting on day 1, it will get over on day 6, and task D, which is a parallel task, will start on day 1, and starting on 1 having duration of 7 days, it will get over on day 7. Task A and D, completion of these two will kickstart the start of task B. So even though task A is getting over on day 6, but task D is getting over on day 7, and B cannot start until A and D both are over. So the earliest start date for B is day 8, and starting on 8 having duration of 5 days, earliest finish date for task B is 12. Finish of B will kickstart C and E. So since B is getting over on 12th, task C and task E both will start on day 13. Task C having duration of 8 days, it will get over on day 20. And task E having duration of 9 days, it will get over on day 21. C and E both are getting they are getting over on 20 and 21 respectively, and finish of these two activities will kickstart task F. F has two predecessors, so it cannot start until both are finished. So the earliest start date for F is day 22, and having a duration of 5 days, it will get over on day 26. So this is our forward pass where we calculate early possible start date and early finish date for each and every activity. Is it clear to everyone? Anyone has any question in the forward pass? Okay, thank you. So once the forward pass, you have calculated the forward pass, now we need to go backwards. We will calculate backward pass. And backward pass is, we will start from this last day and we will calculate the late start and late finish for each and every activity. Okay. Here we calculated early start, early finish, and now we are going to calculate late start and late finish. So going backward, this task is getting over on date 26. Finishing on day 26. To allow this to finish on day 26, latest by which it must start is day 22. Okay. To allow F to start on 22, C and E both must get over on day 21, latest by day 21. Now here, task C, to get over on day 21, latest by which it must start is day 14. And task E, to get over on day 21, latest by which it must start, task E must start is day 13. So C and E both are starting on 14 and 13 respectively. Okay. C has no issues, but E has to start on 13. So task B must get over on day 12. If it goes beyond day 12, then this task will be delayed. So B has to get over on day 12, and to get over on day 12, latest by which it must start is day 8. And to allow task B to start on day 8, task A and D both must get over on day 7. And task A, to get over on day 7, latest by which it must start is day 2. And D, to get over on day 7, latest by which it must start is day 1. Okay, so this is your backward pass. Any questions on the backward pass? Is it clear to everyone? Yeah, Shikant, how did we get 2 as latest start? Okay, I will come to that. I'll explain that. Here you can see task A has a duration of 6 days and task D has a duration of 7 days. So task A and D both must get over on day 7. And task A, to get over on day 7, latest by which it must start is day 2. Because if you count backwards from 7, so it is 7, 6, 5, 4, 3, 2. Day 2. How I calculated this, I mean, you can use this formula as well here, which probably you're not able to see. Okay, I'm sorry, it is missed in this one, but you need to include this day 7 in this. So 7, 6, 5, 4, 3, 2. It must start on day 2. So that is the latest start date. It means if it goes beyond day 2, then you will not be able to complete it on 7. It will get pushed beyond this. Is it clear? Okay, thank you. And after we calculated the forward pass and backward pass for each activity, now is the time to calculate float. So formula for float is, I'll take you to the next slide. Formula for float is LS minus ES or LF minus EF. Okay. So what we need to do is we need to find out what is the float here. So LF minus EF, 26 minus 26 is 0, or LS minus ES. So that is also 0. Okay. You need not to do both. You need to do just either LF minus EF or LS minus ES. And you do this for all the activities, and then you will be able to see the float here. So for task F, the float is 0, C is 1, E is 0, B is 0, D 0, but A 1. And wherever you see the float as 0, it means it's a critical task. Now, let us look at this again. Task A, it has an option that it can start on day 1 and finish on day 6. Or it can start on day 2 and finish on day 7. Okay. No matter what path you take, it is not going to impact the next activity. Suppose there is a delay of 1 day in this activity. Let's say activity A gets delayed by 1 day. Is it going to impact B? No. because you have a buffer of 1 day. You have the float of 1 day. So float, slack or buffer, they're all one and same thing. Okay. If you look at task D, so no matter what path it is using, forward pass or backward pass, it has to start on day 1 and it has to get over on day 7. It cannot afford even a single day of delay. There is no buffer here. There is no float here. If this task gets delayed, your overall project finish date will also get impacted. Your next task will get impacted, B, and your finish date will get impacted. You will not be able to finish this on day 26. Okay, so that's why this will be identified as a critical task, and all the critical tasks will form your critical path. Can you guess why we identify this critical path? Okay, I can see few answers here. Identify your schedule dates. Randy, yes, you're correct, but that you can identify even without identifying the critical path. And yes, Shrikant, you got it right. Ensure there is no slippage on the critical path. And Randy, you are absolutely right to determine what task to monitor closely. I'll add this word, closely. And shortest time for the project, schedule variance, yes, absolutely correct. So the purpose of identifying critical path is so that you can allocate your resources in such a way that they have minimum impact on your overall project schedule, and also during the course of the project. In case if there is any deviation, so you can find out, or in case if you need to squeeze your schedule, you know that which activity you need to pay attention to. So you will monitor these critical activities very closely. You will do the resource allocation, and if you have identified the critical path, you can do it by having minimum impact on the overall project schedule. Okay. In case if you need to squeeze your schedule, or you need to cover up, there is a delay and you need to take some corrective actions, or you need to fast track your project, so you know which are the activities you need to pay attention to. So there is a point, what paths are high risk? Yes, the critical path means it is on a very high risk with respect to the schedule. Remember, this word critical has absolutely nothing to do with the nature of the work. It is associated only with the criticality of that task with respect to schedule. The impact of the schedule of the task on the overall project completion date. And that's the reason we need to identify the critical path. Yes, Thambi, you are absolutely correct. This is for the prioritization. Which task should get priority, which one should not. So with this, we need to understand one more topic with respect to the critical path, the float. So there are two types of float. There are actually multiple types of float, but I will talk about only these two. One is a total float, and second is a free float. Just remember, the definition can be confusing right now, but remember, whenever we talk about total, the moment you see this word total, it means we are talking about the impact of delay on the overall project duration. Whenever we talk about the free float, it means we are talking about the impact of delay on the successor or next activity. In PMP examination, if you see this word just float, if it is written only float, do not get confused whether it is a free float or total float. Float or total float is one and same thing. If PMI has to ask you any question specific to the free float, they will write it explicitly as a free float. Okay. So, is it clear to everyone? And formula for float or total float is simple: LS minus ES or LF minus EF, which is here. You need to calculate LF minus EF for each activity and you'll find the float. Now, the formula for free float. Free float means amount of time by which an activity can be delayed without affecting the successor or next activity. So how to calculate the free float is early start of successor. For example, if I ask you, What is the free float of task C? So free float of task C means early start of successor. What is the successor of C? Task F. And what is the early start of F? 22. 22 minus early finish of the predecessor. Which is the predecessor activity here? C. So 22 minus 20, and because we are using day 1 as our base or the starting day, we need to do minus 1. So 22 minus 20 minus 1 is your 1, which is your free float. In this example, our total float and free float is same. Float for this task and free float is same, but you may get a very complex question in the PMP examination where it will be different. Anthony, you lost my voice. Are you all able to hear me clearly? Can you just confirm it on the chat window? Okay, so maybe Anthony, you need to check something on your side. I'm so sorry for this inconvenience. Okay, so Rory has a question. Task A and task C each have float of 1. Okay. Okay, I got your point. So when I say calculate the total float does not mean that you're going to do this 1 plus 1. No. We do not calculate for the total float for the entire project. No. The word float, be it total float or be it free float, it is always with respect to one single activity. The only difference is total float means amount of time by which one particular activity can be delayed without impacting your overall project duration, overall project finish date. Okay, and when we talk about the free float, amount of time by which an activity can be delayed without impacting the next task. Do not think that the moment you see total, you have to add up entire float. No, never. You will never ever do that. Okay. Randy, very interesting question. On the PMP examination, would we expect to see a diagram like this? No. You will never get this diagram, but what you need to, you are going to get this in the text form. It will be in a paragraph form. So whenever you do get this question for the critical path, do not try to do any mental calculation, mental math. You will be given a piece of paper and a pencil. Draw exactly similar kind of diagram in the rough notebook which is given to you. Okay, put 4 corners in each of the box and calculate early start, early finish, late start, late finish for each activity and connect them as per the sequence or predecessor information given in the question. Then only you should do that. Okay. So this is the way we are going to identify our critical path.